Hello ladies and gents, Sina here. In this video, I'm going to show you how to put together a single procedural shader that can generate a variety of volumetric clouds, which you can then use to turn your scenes from this to this. All you need to get started is a cube to contain the volumetric clouds, and a rather bright light to illuminate those clouds. Keep in mind, this procedural cloud shader works both in the eevee and Cycles render engines. With that being said, in this video, I'll be using eevee to get faster render times. To increase the overall quality of the scene, we can change the sample count of the render engine, but to increase the quality of the clouds, we need to use the volumetrics properties. Here, we can reduce the tile size and increase the sample count to get better results. Additionally, to get shadows on the clouds, we need to enable the volumetric shadows option. Finally, let's create a material for the cube. And with that out of the way, we can now head over to the shading viewport. To get volumetric clouds, we need to create a 3-dimensional texture, so delete the principled BSDF shader. Then press Shift A to bring up the Add menu, and using the search field, drop in the Volume Scatter shader. Make sure to connect the output of this shader to the volume input of the material node. Now, to divide the cube into separate patches of cloud, use the Add menu again, this time to bring in a Texture Coordinate node, a Voronoi Texture node, a Map Range node, one math node with its function set to power, and another math node set to multiply. The Voronoi texture generates a cellular 3D texture that divides the cube into separate puffs of cloud. Let's set the Voronoi texture to 4D so we can later use the W value to animate the clouds. Also, make sure to select the Smooth F1 function to avoid having hard edges between the patches of cloud. The Map Range node allows us to remap the output of the Voronoi texture so we can change the size and the distance between each individual puff of cloud. I have set the Map Range function to stepped linear. This enables us to use higher step counts to make the clouds look realistic, or to use lower step counts to give the clouds a more stylized appearance. The Power function smooths out the edges of each puff of cloud, while the Multiply function enables us to control the density of the cloud. This branch of our procedural shader generates separate patches of cloud within the original cube. As you can see at the faces of a cube, the cloud suddenly cuts off. To fix this, let's smooth out the outer sides of a cloud by adding a mapping node, a gradient texture node, a map range node, and a math node, which we then duplicate by pressing Shift D. Make sure to use the generated texture coordinates. The origin of these coordinates are then relocated to the center of the cloud object using the mapping node. As a result, the center of the gradient texture will coincide with the center of the cloud. Now, if we change the gradient texture from linear to spherical or quadratic spherical, we can make the 3D cloud texture smoothly fade away from its center towards the surface. The Map Range node allows us to control the density of the cloud as it changes from center to surface. Set the first math operation to power so we can control how fast the cloud fades away at the surface, and set the second math node to multiply to make it combine the two branches of our procedural cloud shader. We can increase the density of a cloud by increasing the multiplier of the last math node. Our procedural shader now generates separate patches of cloud that fade away towards the faces of the object. But the result doesn't look like proper clouds yet. It looks more as if someone ejaculated in space. So to make these questionable patches look like proper clouds, let's add a Mix RGB node and a Noise Texture node. These two nodes distort the output of the texture coordinate node, which will make the edges of each patch of cloud look fuzzy. We can change the intensity of the fuzziness using the slider on the Mix RGB node. Now, to control the overall shape of the clouds, let's add a vector curve node. Make sure to select the z-axis and then change the curvature to achieve different cloud shapes. This will specifically remap the z-coordinate to stretch or flatten the cloud along its height. I highly recommend playing around with this curve, as it allows you to create a variety of interesting shapes for your procedural clouds. Another way to control the shape of the cloud is by adding a mapping node. This mapping node allows us to independently scale the Voronoi texture along the X, Y, and Z axes. With these scale values, you can achieve a single puff of cloud or even large-scale cloud formations. Put together, using these parameters, you can generate a variety of shapes and formations for your clouds, and with the help of these fields, you can even animate the clouds. Here are some examples, along with their parametric values. If you want to learn how to create this reverse fracture effect using geometry nodes in Blender, consider watching this next video.